In this lesson, we are going to go through some of the applications in the guide. So these are all from box D. Okay, so let's look at one where we want to find the coordinates of the point where the tangent to the curve is horizontal. Okay, so the tangent to the curve is the derivative of this function. And where it is horizontal is where the slope of the tangent is going to equal 0. All right, so we'll just write that in here. So slope will be equal to 0 if it is horizontal. So what we want to do is differentiate the function cos x plus sin x. So the derivative of cos x is minus sin x, and the derivative of sin x is cos x. I'm just going to put the cos x first because it's positive, and the sin x second because it's negative. Not a big deal. Okay, now this is the slope of the tangent to the curve, so I want this equal to 0 because it is a horizontal line. So let's set it equal to 0. And we want to solve for x. So what I'm going to do is bring the negative sin x to the left to make it positive. And one useful thing we can do, let's change colors here, is I'm going to divide both sides by cosine x. And this is quite a common thing to do, because what happens when we do that, let's do it in red. So let's divide both sides by cosine x. So remember that you can multiply or divide any equation by any value as long as you do it to all terms. So cosine divided by cosine is 1. And then sine over cosine is equal to tan. And so by doing that, I've gone from two unknowns, cosine and sine, to one, which is tan. And that's just a useful tool. So now I can find the value of x by taking the inverse of tan, which is going to equal 45 degrees, or pi over 4 if you're dealing with radians. So now I know that the angle x is 45 degrees. So that is the point, or well, let's put or pi over 4. I believe the answer is in radians. So I know the point's going to be pi over 4, and now I need to find the y coordinate. So I'm going to go back to f of x and determine what the value is at pi over 4. So it will be cosine pi over 4 plus sine pi over 4. So if you think of your special triangles, cosine of pi over 4 has an exact value of 1 over root 2, and so does sine pi over 4. And so we get 1 over root 2 plus 1 over root 2 is 2 over root 2. I believe they rationalized the denominator. So let's multiply the denominator by root 2 so that we get 2. We have to do the same to the top. So that's going to give me 2 root 2 over 2, which will reduce to root 2. And so this is the coordinates of the point to where the tangent to the curve is horizontal or has a slope of 0. Okay, in this example, we're trying to carry a rod around a corner. So this is actually a good question to look at when you're trying to move furniture, as you all will do at some point. You're all going to get your own place, and you're going to have to figure out whether this chair or this couch is going to fit around the corner. Okay, so we have a 3-meter wide corridor that makes a right angle as shown in the diagram. So let's just draw the diagram. So we've got a corner here, and then we've got a corridor around that we want to fit, and then this corridor is 3 meters wide. And we want to see if we want a rod that fits around this corner. So we want, let's draw it in blue. So we want to know the longest rod that's going to fit around this corner. Okay, so let's again divide it into 2 parts. So we'll call this L1 and we'll call this L2. And so L1 makes a right angle triangle with the adjacent side being 3 meters. So this angle here is going to be the same as this angle, and this angle has an opposite side of 3 meters. So we'll use what we did in the last question. In L1, so we'll say cosine theta is the adjacent side, which is 3, over the hypotenuse, which is L1. So L1 will be 3 divided by cos theta. And then we'll do the same with the second part, which has the opposite side. So sine theta, the opposite side is 3 over the hypotenuse, which is L2. So we're going to have 3 over sine theta. Okay, and then the total length of the rod is going to be the length of L1 plus L2. So L1 is 3 over cos theta and L2 is 3 over sine theta. So this is very similar to the question we just did. So let's change cosine, 1 over cosine to secant, and 1 over sine to cosecant. So this is our length equation. We want to minimize, well actually we want to maximize the length. We want the longest rod. So let's find L prime. So that will be 3 secant theta tan theta plus 3 cosecant theta cotangent theta. Sorry, minus. And let's change secant to 1 over cosine, tan to sine over cosine. So we want everything in terms of sine and cosine. We've got a negative here, so minus 3. We'll change cosecant to 1 over sine, cotangent to cosine over sine. And then we will just tidy it up a bit. So we've got 3 sine theta over cos squared theta minus 3 cos theta over sine squared theta. Then we'll solve. So we set this equal to 0. Then I'll bring this negative term to the left. And then we'll cross multiply. So we will get 3 cos to the power 3 theta equals 3 sine to the power 3 theta. And then let's isolate for the variables. So 3 divided by 3 is 1. And then we'll get sine to the power 3 theta over cosine to the power 3 theta, which equals tan. And so in order to find tan, we're going to take the cube root of 1. So tan theta is going to be the cube root of 1. So the cube root of 1 is just 1. So I want the angle, so let's do shift tan or inverse tan of 1. So theta works out to be 45 degrees. And once you have that angle, you can go back and find the lengths. So length 1 was 3 over cosine theta, so 3 over cosine 45. The answer in this is from the guide, so the answer given is given as an exact ratio So cosine of 45 is 1 over root 2. So I'll simplify that to 3 root 2. And then the same for the length 2, 3 over sine 45. So sine 45 is also 1 over root 2. So we'll simplify that to 3 root 2. And then the total length will be 3 root 2 plus 3 root 2, which is 6 root 2. So the reason I'm doing inexact is because in the solutions it's given as an exact answer.